So for this video, I want to address a difference quotient problem. So as you can see, here is my difference quotient. And for those of you that have an understanding of calculus, you can see that this is setting the foundation for that because this is the formula that we apply when we start doing differentiation. So I'm going to start with this. I'm going to give you this f of x. This f of x is x squared minus x plus 3. And I'm going to use this function and apply the difference quotient to it. So I'm basically going to do all of this to this. So let's first start out with what we know. Well, we know what f of x is. And I see right here that I am subtracting the quantity of f of x. So if I had to write this down and what I know, well, I know the h, that's fixed, that's nothing to do with that. I know I'm going to have a minus, and I know what f of x is, and that's that x squared minus x plus 3. Okay, but what is this f of x plus h? Well, let's kind of go back to what we know about formulas, or functions, I should say. If I had f of 1, I know I'm going to take that 1 and I'm going to plug it in for every x there. So that would be 1 squared minus 1 plus 3. So 1 minus 1 plus 3, which would just simply give me 3. So I know when I input a 1, I get out a 3. If I were to write it as an ordered pair, that would look like 1 comma 3. And then thinking even more, okay, so what if I had f of, let's say, let's be crazy, let's do q. If I had f of q, it would work the same way. I would just put in a q wherever there's an x. So I would have a q squared minus q plus 3, and there's nothing I can do with that, so I'll leave that alone. So therefore, if I understand that principle, then solving for f of x plus h isn't so hard. That just means I'm going to take x plus h and plug it in everywhere there's an x. So I'm going to need a new page. So f of x plus h is going to look like x plus h squared minus x plus h plus 3. And again, recall that it originally was x squared minus x plus 3. So you can see I just put in an x plus h everywhere there was supposed to be an x. So now I'm going to work with this, and this really just takes basic algebra or some, I just say some algebraic principles to solve. So this isn't anything too scary. First, I have this x plus h squared, and I have to understand that means x plus h times x plus h. And if I foiled it on up, I would end up with this x squared plus xh plus xh plus h squared. So then I get x squared. I'm going to make these alphabetical. So that's plus 2hx plus h squared. Again, I recommend making sure, knowing the shortcut where you take this first term, square it, take this times this, and then double that, and then take the last term and square it. That's that little shortcut, which would be in a different video. But if you don't know that shortcut, just go ahead and FOIL it on out. So now I have f of x plus h, which is going to be equal to x squared plus 2hx plus h squared. And then I'm going to have to distribute this negative sign up, so minus x minus h plus 3. So then if I look at this and I'm going to say, oh my gosh, there's nothing actually that I can simplify there. So I'm going to go ahead and transfer all of that over. I'm even on the side writing this all down so I can transfer it, make sure I transfer that correctly. So I'm going to go back here. And I am going to see that f of x plus h, that gives me that, what I just found, x squared plus 2hx plus h squared minus x minus h plus 3. Lots going on. So now I'm going to work with this, and I'm going to start by distributing this up. All right, so I hope everybody has this. I mean, if you're following along and you're writing this down, write this on down because I'm going to need a new page. I tend to write all over the place, so I'm going to need a new page for this. So let's go back over here. So I know I have this x squared. I'm going to put a little side. So f of x plus h minus f of x all over h equals this x squared plus 2hx plus h squared minus x minus h plus 3 minus, and remember I had minus the quantity of the x squared minus x plus 3, and then I have to distribute that in. So that is minus x squared plus x minus 3 all over h. So now I'm going to look and say, can I simplify this? Well, let's see. And minus x and a plus x, that just cancels. I see it here again. A plus 3 and a minus 3, that's going to cancel. Oh, my poor little x squares, they're going to go bye-bye as well. So I'm going to end up with 2xh plus h squared minus h. And I'm going to circle this. This is what I have left. All over h, because I can't forget that. So then I'm going to divide it by the h, and I see that this is going to cancel, and I see when I do this, one of these are canceled, and this is going to cancel and just leave me 1. So therefore, I have 2x plus h minus 1, and I'm just going to rewrite that 2x minus 1 plus h. And that is going to be my final answer for this. So in conclusion, if I applied our little difference quotient problem with what is f of x plus h minus f of x all over h, I find out what f of x plus h is, which is what gave all of this craziness right here. I'm subtracting then what f of x is, which I know to be this right here. All over h, you can see I simplified and then I divided all the terms in the numerator by that h to end up with 2x minus 1 plus h. And as you proceed and you get into pre-calc and calc, you realize that that this is setting the stages for to find the derivative of this, and as h approaches 0, you end up with just simply 2x minus 1. So I hope you enjoyed this video, and I hope you found that something that started initially to be really huge and really confusing, you see that when you break it down to its steps, it's not so bad after all.